Hello, my DevNation friends from everywhere in the world. Thank you for coming for another DevNation Tech Talk. And today, well, right now we have a storm going through here in Cary, North Carolina. I hope you're all safe. And of course, we still have the pandemic going on. But no worries. We have a very special guest today. Christine Flood is going to be talking everything about Java and containers, and I'm sure you will be amazed by the content. And without any other further delay, Christine, the stage is yours. Welcome.
Hi, everybody. I'm here in Massachusetts where the weather is gorgeous, but we'll see how it goes. I submitted the abstract to this talk, Java and Containers, What's There to Think About. But as I was writing the talk afterwards, I think a better title might be Adventures with Containers for JVM Hackers. I am not directly involved in our container effort, but I am on the OpenJDK team, and I've spent some time playing with containers, and I have spent a lot of my career dealing with JVM performance. So first, a little bit of history. Kind of the evolution of Duke. When I first started working with Java, it was back in the 1990s, and the thing we were most concerned with, we wanted to be able to download bytecode from the web and run it safely on whatever machine people were using, heterogeneous architectures. So everything was about bytecode verification and making sure that it was safe. And then in the 2000s, everything was about making sure that Java was fast, right? You could use all the memory on the machine. You could use all the processors on the machine. The only question was who could get, Volanimark or whatever, who could run it the fastest. And then in the 2010s, it was all about smooth Duke. I'm pretty pleased with these pictures. Oh, and by the way, if you have any questions, feel free to post them on YouTube. I like to be interrupted. I like to have a dialogue if at all possible. So smooth Duke. This came the era of quality of service guarantees, and folks wanted to be able to promise response times in under 10 milliseconds. And so all of our JVM work was focused on making sure that garbage collection pauses were really short, making sure that things could get processed quickly. But now it's 2020, and what people want is to fit as many Java virtual machines inside of containers on a physical box as possible. So what we're optimizing for now is we want a smaller footprint, we want faster startup, and we want smaller image size. So I'm distinguishing between the footprint and image size because the image size is the thing you download to start running, and the footprint in this context is how big the JVM is when it's running your program. So when I agreed to give this talk, I thought I'd be talking old school and about what kind of things you can do with OpenJDK to make your JVM smaller. Things that you can do. So for example, if you're running in a container and you only have one thread, you might want to think about using serial GC. It's not as well maintained, it's not the default, but it was, it's been there since the very early days, and it's meant to share a single thread with your Java program. You can adjust the GC heap parameters saying, oh, don't grow the heap so fast, let's small, or let's shrink the heap faster and try and get it back down. You can adjust how much time you're spending in garbage collection. So the default is that you're going to spend 1% of your time doing GC. Maybe you want 25% of your time doing GC and keep your run size smaller. Adaptive size policy weight, there are folks who have found that this helped them a lot. It's simply a scale from 0 to 100. If you adjust it up, then it's sort of like a knob that says, okay, let the GC do more perturbations to try and have it exactly where your program needs it in terms of memory space. Okay, so there are some more command line parameters. There's native memory tracking. So if you use these options, native memory tracking summary and print NMT statistics, you can see the difference between what you asked your program to use in terms of a heap size and the memory it's actually using. So there are things that your Java program needs to allocate, like, say, a card table for the garbage collector, or other sorts of things that the JVM needs to run that aren't in the heap. And this will give you the ability to look and see how much memory all those things are taking in case you want to shrink that. Each Java thread has a stack. So you can decrease the Java stack size. If you make it smaller, then that's less memory that your program will use. And finally, I put this at the bottom. If you want to see what the default is for all these parameters, you can print out all of the flags and you can see what you're running with and how you might want to adjust them. Okay, so...
And on the previous slide, you said that, well, the default for the stack size is 1024, 1024. From your experience, what is a common recommendation for the stack size on most production workloads?
Well, as I put here, it was 228K is something that seems to work. It seems like it's a good place to start. If you set the stack size to 228K and your program still runs, you're good. Maybe you can even dial it down further.
Okay, so if it doesn't work, does it mean we'll get Stack Overflow errors?
If it doesn't work, your program will fail with yes. And so that's just a place to start, and you can tune it. And again, I am sort of shooting in the dark here because I have no idea what your program is and how deep your function calls go. So it's just a parameter for you to play with, and give yourself a little wiggle room, because just because it ran in a certain stack size this time doesn't mean that it will always run in that stack size. So the goal is not to get stack size to the absolute lowest it will ever run in, but just to get it small enough so that you're confident that your program will always run, but you can still save some memory, because 1024 is probably bigger than you need.
Awesome, thank you.
Okay, so I really am supposed to be talking about containers, and that was all old school, just giving you what some parameters are that you can play with in the JVM to make things smaller, but you're really running in a container, and you can still run with those parameters. This is just showing you how to run Java inside of a container. I have a program that I'll talk about in a little while called Test Random. And you can just add the class file to your container, and then you call it via a command. And you can play with all those parameters into a container and see how they affect your program. Now, my experience has been that things don't always behave in a container the way I expect them to. So to play around with this and look at PS and see what your container is doing. I have set up running Java with like a 2 gig heap size, and when I look at the process, the RSS is not that big. So the kernel is smart enough to say, well, as long as you haven't looked at this area or touched this area, I'm not going to give you that memory yet. So it's an interesting dynamic and something fun to play with. So we recommend that you use Podman here, and so you can, if you take the contents in the first part of the slide and put them in a Docker file, you can build that, and then you can run the thing that you. So I added this thing here called X show system settings, show setting system. That gives you some interesting information, especially if you're running with cgroups v2. So you can see what of the container are. And this is interesting from a Java perspective, and I'll get into that a little later. But you can set these things. So you can say that you only get sort of half of a CPU, or that even though you're running on an 8-processor system, you only get one processor. So my test random program, this is my favorite program. When I need a Java program to play with, it's what I do. It creates an array with the number of bins set to the first parameter, and then it generates as many random numbers as the second parameter, and it puts them in bins. So it's just a tester for a random number generator. You would expect things to be approximately equal at the end of it. So what can we do with our containers to make them better? The first thing is checkpoint restore. Now, I've been working on checkpoint restore from inside of Java for a long time, but that doesn't work inside of containers right now. Right now, you have to checkpoint the whole container. So it's pretty straightforward. It copies the entire container to a disk in the middle. So you're running your Java program, you're halfway through, you can copy it all out to disk, and then later on, you can bring it back in. So this can be really, really efficient. If what your container is doing is if what your Java application does is it does a lot of class initialization, it does a lot of warming up of the JIT, it has a lot of garbage sitting around. If you can catch it at the right point, you can checkpoint it out to disk. And then later on, when a request comes in and you need it, all you need to do is restore that image, and it's very fast. It's within the order of milliseconds. So if all of your concern is in startup time, checkpoint restore gives you an answer for that. So we have our Podman container. We're running it. It's really easy to do checkpointing and restoring. It's a simple command at the Podman level. So I don't think there's any way to make that even simpler. All right, the one thing that I do have to let people know, I've tried to make all of my examples runnable, and if you're running Fedora 31, it's using cgroups v2, and checkpointing isn't working. So I had to run some.
Oops, Christine, it seems that we lost your audio.
I'm sorry?
It seems that we lost your audio for a bit.
Can you hear me now?
And now we can hear you, but we lost the screen share.
Okay. Let me see what I can do.
No worries, that's what happens when we're trying to do some things live. And if you're watching this, I hope you're seeing a lot of useful information. And yes, I'm getting a lot of new information. And actually, Christine, I can see your screen now, and I have a question for you.
Okay.
You've shown this podman commands for checkpoint and restore, just in case somebody isn't using Fedora Linux or Linux at all. Can we do a checkpoint and restore using Docker, for example?
Okay. The checkpoint restore folks have done the work for Podman, and they've done the work for Linux. So if you're running Windows, there's no hope. If you are running Docker, I know that I have seen it work and I have played with it. I am not certain that it is currently maintained. I would have to look into that. And if you want me to look into that, send me an email. I'm CHF at Red Hat, and I will go and double check.
Okay, thank you.
All right. So another way to reduce the size of your image, or to make faster startup and lower memory, is to use a native image. So I have two ways of using Substrate VM. Now, I'm going to be honest with you guys. We're all nerds here. Up until a week ago, I'd never used Substrate VM, but I couldn't give a talk like this without talking about it. So I believe that we call it Mandrill instead of Red Hat. The Sun Labs project was called Substrate VM. Basically, what it does is it gives you the ability to turn your Java program into a simple Linux executable. So if you look at what I've got set up here, I'm bringing in an image, so I'm bringing in the Quarkus Mandrill image, and I can use the native image command to generate an executable, which is testrandom.out, and then I can run that image, which will run that command. Now, this is not the most efficient way to do it. My buddies that are on the Quarkus team are saying that it's inefficient to generate the executable and run it in the same Docker container, that you'd probably want to generate it in one and then you can run it over and over again in a smaller one. I'm just showing you what worked for me. If you're an old Java hacker and you want to play with it, this is a pretty simple way to get it to run. You could also, rather than doing all of the Docker file stuff to get it to run, you can run it on the command line. And I have put a command line here that shows you how to do that. I'm not going to dive into this because it's horribly complicated, and I think the Docker file is simpler. But if you have questions, I can help. But it's worth trying it because it's pretty cool to be able to run your Java program without all of the JVM. Now, I do want to say that if you are doing anything like dynamic class loading, so if you don't have a closed world when you start, then you can't use Substrate VM. The only limitation is that you have to know all the classes that you might use when you build the executable.
Christine,
yeah.
We have a question from Alexander. What's the difference between Substrate VM and Graal VM?
Same thing. Same thing. I should have called it Graal VM, actually. I'm just an old... It was Substrate VM, and then it became Graal VM. So, my bad. I still think of it as Substrate VM. Anyway, where was I? When it was a labs project at Sun Labs, it was Substrate VM, and now that it's out in the world for running Graal, they've renamed it as Graal VM. Okay, so the second command down here will generate testrandom3.out, and then you can just execute that as a command line, or you can put it in a container and execute it there. So, just for grins, this is a little bit controversial, and I will admit that, but just for grins, I ran a native image, which is using Graal VM, and I ran the same program using OpenJDK. And for this particular application, which is just allocating an array, generating a ton, or however many this big number is over here, of random numbers and putting them in an array, the performance is roughly comparable. The elapsed time is slightly smaller for OpenJDK, but the user perceived time is smaller for the native image. And the space it's really it's in the noise what the difference is. But I want to say from the beginning, when I set up to do this talk, I was playing with my favorite program, right? I am virtually certain that if you ran a program that did a lot of class loading or a lot of manipulation of data that was bigger than ints, that this difference would be striking and the native image would be smaller and faster. I want to bring the podman ps command to your attention. When your containers are running, you can look and see what they're doing. Here you can see that I'm running, one of the tests random.out, which is the native image, and one of them is running the JVM, the Java command. And so it's one way that you can look at what's going on inside the container. Okay, so there are some questions that I promised I was going to address in this talk, and I didn't. So I want to just talk a little about what that means. And the reason I want to do that is because I don't know what this means, and so I want to start people thinking about it. What happens if you try to run OpenJDK on a partial share of a processor, right? When we started out, we talked about how Java grew to be able to take over all of them, to be able to run a parallel garbage collection that used all the processors, to have separate threads for compilers and cleanup and whatever. So if you go and you run your JVM on a partial share of a processor, I don't know that all those things are going to work well. And I had hoped to be able to do some runs and to show you, but now I'm just going to ask you to think about it. What does it mean that you have half of one of the processors on your machine and you're running this program that was meant to have all these threads? If you just run the default on the machine, it runs a parallel garbage collector. That doesn't make any sense if you've only got a single processor or a partial share of a processor. So I want people to start thinking or to start talking about what we can do for OpenJDK if that's what we want. If we want to keep pushing OpenJDK to work well in containers, make it run well on a single processor. And I gave a quick talk. I always give a quick talk, but if you have any questions, feel free to email me. I love to interact with customers. I want to make sure that the things that I'm working on are the things. Right now I'm focused on doing checkpoint restore from inside of Java, so call out and do it. But if there's things in the container world that you want to see happen, let me know and I'll see what I can do. Are there any questions? Okay, it sounds like there aren't any questions, so I guess we're going to end a little bit early. I want to thank you for your time, and I appreciate your attention.
Oh, sorry, Christine. My bad. I was on mute. And thank you, Marcus. Now it was a human technical issue, or not that technical, it seems. I have a question from Lucas. Like, if we're working with a thread pool, is there a way for me to limit the execution of the thread pool, like a total execution time?
Yes. Let me see if I had that slide. I meant to put that slide up, and maybe it didn't make it in. Oh, okay, it did make it. If you go and look at the podman run command, there are ways to say, I want to only use this CPU set, these 3 processors, or I only want to use this amount of the thread quota. I had very much wanted to give some examples of that in this talk, and I just ran out of time. I apologize. If you guys want me to give another talk where I go into the details of what does it mean to set the, somewhat ludicrous bounds on the container that your Java program is running in and what happens, I'm happy to do that.
Awesome. Let me see. Frank Kelly has a very interesting question here. Christine, would you say it's a bad idea to run Java in production allocating only one vCPU to the container?
I think that, let me take a minute. I don't think that's a problem. I think that Java can run well in one CPU. I think you need to take a little bit of time to play with some options. It will run well, and OpenJDK can run well. The Graal VM can certainly run well in one processor. It's not what Java evolved into in the early 2000s, but it can still handle it well. I have not done a whole lot of experiments, and I'd like to, with figuring out how to make Java run well with limited resources, like you said, one processor or a share of a processor.
Okay, and another question from Guy Dumas. People still configure memory size with power of 2 units instead of like round numbers. It made sense with bare metal processes, but inside the JVM, is there a gain? I personally configure round figures like 1,000 instead of 1,024. Is there any difference?
Okay, so inside the JVM, if you're talking about your heap size, it really doesn't matter. If you've got a region-based collector like G1 or Shenandoah or ZGC, it's going to break the heap up into a particular chunk size. And whether you have, 16 chunks or 18 chunks, it really doesn't matter. Or maybe more likely, 2,000 chunks or 2048 chunks. It doesn't matter. No, there's no reason. There's something tidy about powers of 2, but I don't think there's a performance difference. I have not seen a performance difference. I never worry about it.
Yeah, good to know. I didn't know about it either. And I think the last question here on the chat is from Lucas again. Like, I work with Docker and I have many containers running in my cluster in production probably. How do you deal with the competition between those containers? Is there anything we can do, or each container is independent from each other?
Okay, so here we're going off into my ivory tower. There has been a paper, and if you send me an email, I will find it for you. There has been work done on getting JVMs to cooperate. So, for example, when I talked about how you can have a parallel garbage collector, so you can have a Java program that's single-threaded, and then every time it goes to garbage collection, it uses 8 processors, right? And so, if you want all of your JVMs to sort of coordinate and agree and say, okay, well, we're only going to garbage collect, only one of us can garbage collect at a time, for example. There was a paper by Jeremy Singer on how to get JVMs to do that and to coordinate those things. But it's all academic at this point. There is nothing that I know of in production in the real world to tell JVMs to coordinate when they do highly multi-threaded work.
Awesome. Well, we're already on the top of the hour now, and if you have any further questions, I would ask you, Christine requested you send her an email at chf@redhat.com.
Yes.
And yes, so please. So, yes, Thomas, please send an email to Christine. She'll be more than happy to reply to you. And if you're watching this, thank you very much for staying with us until now. It was a super interesting talk. And Christine, the DevNation team, thanks you again very much. And if you ever have any other interesting subjects, we'll be more than happy to have you again.
Thanks, everyone.
Okay, bye, and see you next week on the next upcoming DevNation Tech Talk.